How many viewers am I up to?
You had 20, and then your highest video was 51
20 subscribers, and I have 51
views. On your highest.
not likes, just
I didn't
51
say
views. 51 views, people, keep watching. Okay, so today we're going to move on in the circles chapter. Okay, so first we're going to apply properties of chords. All right, so let's review. A chord is a segment whose ready? Okay, that's okay. A chord is a segment whose endpoints are on the circle. Okay, so a diameter is a chord. So here's the center. I draw a line segment and I have it go through the center. That's an example of a chord. A special kind of chord. We call it a diameter. Okay. So in the same circle or in congruent circles, what do congruent circles look like again? We just reviewed this when we were going over the homework. What do they have?
Circles
have the same radius. So that's 5. That's 5 congruent circles. Okay. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if the minor arcs are congruent, then the corresponding chords are congruent. If the corresponding chords are congruent, then their arcs are congruent. Okay? If and only if. So arc AB is congruent to arc CD. Then we know that, what do we know?
Second
Chord AB equals
Yep.
chord CD.
Now we're talking about the line segment AB, not the length of the segment. So what do I need to put on top of that AB?
A line.
Okay. And then we'll call this DC. Okay, good. Moving on. Example 1. In the diagram, circle A is congruent to circle D. Okay, good. We know that because notice this radius is congruent to this radius. Fabulous. Okay. So BC is congruent to EF. And the measure of arc EF is 125 degrees. Well, that's on the diagram. That's fabulous. I love it when they put our information on the diagram for us. Okay. Find the measure of arc BC. Anyone?
125.
Okay. So, okay, why is that?
That is
Theorem.
congruent.
Because we're in congruent circles,
And the lines are congruent.
and we've got chords that are congruent. So their arcs will be congruent. Moving on. Okay. If one chord is a perpendicular bisector of another chord, okay, so we take this chord, and we see that it cuts this chord directly in half, and it's perpendicular. It's a perpendicular bisector, cuts it right in half. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So if QS is a perpendicular bisector of TR, then blank is the diameter of the circle. What should that be? QS. Okay. If we know the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord in its arc. Okay? So converse. If EG is the diameter, now we're given the diameter, and we're told the diameter is perpendicular to this chord, then we know that HD is congruent to HF, and these arcs should now be the same length. So we need to say this arc is congruent to this arc. So GF is congruent to GD. How are we doing?
Good.
Okay, let's try to apply these theorems. Okay, using the diagram, a circle, you define the length of, all right, there's circle E to find the length of chord BD. All right, tell what theorem you use. Okay, so suggestions. I see that CA is diameter. It's perpendicular to this chord here. So what does that tell us? If a diameter of a circle, this is the diameter, right? CA? How do I know it's the diameter?
This is the center point.
Exactly, it goes right to the center. Okay, so if a diameter of a circle is perpendicular to a chord, that's what we have so far, then the diameter bisects the chord and its arc. Okay, so we're given the length of this segment here is 6. So what's the length of this segment be?
6.
Okay, so that's an F. So FD is 6, then FB is also 6. Okay, so they're asking us to find the length of BD. So what should BD
12.
be?
12.
So B, I'm just going to write, find the length of BD. All right, so BD equals 2 times FD. And we know FD is 6. How does that work? That's good enough. Any questions? Am I going too quickly?
You're still wearing your snow necklace?
I'm wearing my snow necklace until we get snow.
So there's
People?
on Friday.
It's going to happen.
It says on Friday, but
Really?
What'd they say?
Friday.
I heard March 8th.
Oh no, not the.
I'm moving.
Like March 8th through the 15th. I don't know. I don't want to say anymore because I feel like it's not going to
If
happen.
I move before we get a snow day, I'm gonna be really sad.
Are you moving?
Yeah. I told you this.
That's right. You did tell me. You made me sad again. All right. In the same circle or in congruent circles, okay, 2 chords are congruent if and only if they are equidistant from the center. So, AB is congruent to CD. AB is congruent to CD if and only if they're equidistant from the center. So how should I say that?
FE is equal to EG.
Okay, why did I not put a line over the top of that FE?
There's segments.
They don't have an endpoint.
You see that equal sign? That means we're dealing with numbers, right? Where's it congruent? Here. Well, I guess we can talk about that one. There's another one. Here. Congruent. This means we're talking about names of segments, okay? This, we're talking about measures of segments. Talking about the length is actually equal. All right, so in the diagram of circle F, AB is equal to CD is equal to 12. So find EF. Suggestions? Notice what we have here, the length of these segments. They're both 12, but they're both the same, right? In the same circle, 2 chords are congruent. Okay, we know that 2 chords are congruent. Then we know that they're equidistant from the center. So these chords are congruent, so they should be equidistant from the center. How do we represent things are the same in an equation?
3x equals 7x minus 8.
Okay, so, okay, solve for x.
It's 6. Or well, X is 2.
That's what I got too. Okay, so if x is 2, they're asking us to find EF. Okay, so the length of EF is going to be 3 times 2.
6.
Any questions? What's difficult about this chapter is that none of these formulas are on the formula sheet. So you have to know all this stuff. You just have to know, okay, I've got congruent chords, so therefore they're the same distance from the center. It's not hard to solve this equation. You just have to know how to set up the equation. That's the hardest part. All right. Can I move on? Okay. All right, so my students have already written this down. An inscribed, here's an example of an inscribed angle. So if you haven't written this down, go ahead and press pause and write it down. Okay. An angle whose vertex is on the circle, okay, not in the center. We have been dealing, up until now, we've been dealing with central angles, where the vertex of the angle is in the center of the circle. This is called an inscribed angle. It's inscribed inside the circle. So its vertex is on the circle. And the sides are chords inside the circle. Okay? And this is called its intercepted arc. Okay? It's an arc that lies in the interior of the inscribed angle and has endpoints on the angle, right here and here. Okay? So that's this inscribed angle's intercepted arc. All right, so the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So before, we had, oh my gosh, that circle is pretty close to perfect. Thanks a lot. What does the measure of this angle look like about to you?
45.
Did you say 45? Okay, so, oh, sorry. Okay, so if you've got a central angle, okay, and now I'm going to take these endpoints and I'm going to take the vertex of this angle all the way back to the end of the circle here. It takes this angle and it cuts it in half. So that's the relationship we're learning right now. So the measure of angle ADB is equal to 1/2 of this arc. So 1/2 the measure. So what would the measure of this angle be? Exactly. Okay, and you can tell, look at it. It looks a lot smaller. All right, find the indicated measure in circle P. What's the measure of angle S? Okay. The measure of this intercepted arc, RT here, is 60 degrees. So what does the measure of angle S have to be?
Half the same.
Half, right. So that's going to be 30 degrees. Okay, so then I'd put that on the diagram. It's kind of small for you to write. This one's kind of tricky. The measure of arc RQ. RQ. Suggestions. Take what and multiply by what by 2? So we already figured out the measure of this angle is 30, right? But now we need the measure of this arc. You see how this is the diameter? So that tells us that the measure of this arc is what? Okay, that's 180. All right, so wouldn't it be great if we knew the measure of this arc right here? Q, can't see what letter that is. Is that an S? Because if we knew that, then we could just subtract that from 180 to give us the measure of this arc here, RQ. Oh, we got a 37. 37. What does this 37 tell us? Okay, so what should the measure of this arc QS be? Double, which is? I hear like very, very like, I don't know if I'm becoming hard of hearing.
74.
Say it louder. Okay, 74. Okay, so now we're almost done. Different color. So that's going to be, what's 180 minus 74? How are we doing? Find the measure of arc HJ and the measure of angle HGJ. All right, let's do that. Let's find the measure of this arc first. Suggestions?
Can double 39.
Can double 39, which is going to be what?
Uh,
78.
Okay. And the measure of angle HGJ. HGJ. How are we going to find the measure of that angle?
It's 39 as well.
How do you know that?
Because you said divided 72.
Because this intercepted arc is the intercepted arc for this inscribed angle, but it's also the same intercepted arc for this angle. So this is going to be half of 79 as well. So what do you notice about HGJ and HFJ? We were just talking about that. They're both 39 degrees. Okay, so I should probably write measure of arc HJ is 78 degrees, and the measure of angle HGJ is 39 degrees. Good? This takes us into our next theorem. This is what we just learned. If two inscribed angles of a circle intercept the same arc, then their angles are congruent. That's what we just did. Okay, so here we've got the same exact intercepted arc for this angle and for this angle, which makes those angles congruent. Okay, if we were talking about the measure of each of those angles, they would be equal. The measure of each of those angles is equal, but the angles itself, those angles are congruent. Okay, so this is very wordy, okay, but what this says is, this is common sense. Okay, watch. This is the diameter, right? So what's the measure of this arc? Okay, now we learned that we've got, think of this as the intercepted arc, and this is the inscribed angle. So what's the measure of this angle have to be?
90.
It's half of 180, so it's just going to be 90. Put a right angle there. So if the measure of angle ABC is 90 degrees, if and only if AC is the diameter of the circle. Okay, so if you've got a 90 degree, if the measure of angle ABC is 90 degrees, then this is the diameter. Or if you know that's the diameter, then you know this is 90 degrees. So it's an if and only if. Okay, last one, and then we're going to do an example in your homework packet, just to make sure we understand it. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Opposite angles, okay? Don't get confused between this is a regular parallelogram, which we learned about last chapter, that has opposite angles are congruent, right? This is an inscribed quadrilateral inside a circle where its opposite angles are going to be supplementary, okay? So I'd like you guys to go to the homework packet. On the back of your homework page, let's go to number 16. See if we can't find the value of the variables, x and y. So, I'm going to start with opposite angles should be supplementary. So what's a pair of opposite angles here? Those are opposite. So what do we know about them? They're not going to be congruent. They were congruent in a parallelogram. They are supplementary. So how do we represent that? How do we write an equation to represent that?
you add the
5x plus 110 equals 180 or 104.
Okay, you just said one answer, and you just said one answer. Okay, so we've got 2y plus 104 should add up to 180. And then if we were doing the other pair to find the value of x, 5x plus 110 adds up to 180. This will be on your quiz. If you set them equal to each other, you're going to get it wrong. Opposite angles are not congruent. They are supplementary. Okay. I'll let you finish that in a second. I don't really care about the answer. More about setting it up. And the last thing, the closing task, I want you to see if you can draw a central angle and an inscribed angle. And you've got to know the difference between the two. Okay? So if I make this, what does that look like to you? About 70 degrees? Okay? If the measure of this central angle, it's called a central angle because the vertex is in the center of the circle. If this angle is 70, the measure of that angle is 70. Okay? And if I keep this 70, what's the measure of this angle going to be? This inscribed angle? Half. Okay? So if I take these, what I was trying to do was take these 2 points here and bring them back to the other side to put here. That would be 35. Done. Thanks for coming out.